So we will be discussing rate limiter today. So what's the rate limiter? So it basically allows you to control the requests, number of requests serving on your servers. So basically, why we need this? We need this so that we can protect our services from like DDoS attacks, or from like bombarding number of requests to server, means beyond its capacity, right? So this is the high level why we need this. And also, if you want to uh, if you suppose have multi-tenant kind of system, you want to like control this particular tenant, so we only allow this many requests for the time, for like certain time period, then in this case this is very helpful. So how it works basically, if I give you very high level design. So this is your suppose uh, server, and this is your client. So whenever this client and there can be, so this rate limiter you can implement at two places. Either if you have a gateway, right, so you can implement the rate limiter in gateway, in API gateway itself, or you can implement in server at your server as well. So depending on what your system is, you can implement either in API gateway or server. So in server level, you will have, for sure you will have more control on this rate limiter. So for this session, I will be implementing, uh, like I will be designing the system in a way that I will have rate limiter in my server level. So for the timing, I'm removing this API gateway, because I will be directly implementing server. So at very high level, once the request comes in, it will go to your server, and if uh, for this request, if there is no rate limit you have put in this uh, server level, so what it will do, it will try to serve this request. And due to, suppose already this server is serving so many requests, and you will also have uh, means like, suppose thousands of requests servings, right, but its capacity is like not more than 1000. So the other request in that time will get either get cancelled or timeout, and or it will face latency issue. And due to this, what it will means, there will be so much CPU spike, because since your server is overwhelmed from the request. So you want to control it. You know how your server works. So what we can do is, you can allow your servers to process these many requests at a certain time, right? So this is where this rate limiter comes in picture. So how how it will work with, you can put rate limiter in your uh, server itself. So let me draw this server bigger, so that I can put one rate limiter here. So this is rate limiter. Yeah. So how it will work, once you put the rate limiter, so rate limiter have means has its own implementation. I will talk about this in a while. So right now, with the rate limiter in place at server, so once the client goes, so it will, before serving anything, before processing anything, it will hit the rate limiter, and rate limiter will tell whether this request is allowed to serve or not. If it is allowed to serve, it will process, and it will, depending on the processing, it will send either like 200. Okay, or if it is not this due to the rate limiting, if it is not allowed to it is not allowed to serve, it will give you like 429, which means too many requests. This particular HTTP code, based on your design, we can send whatever you want. Yeah, so this is very high level design. So uh, let's go a bit deeper. So suppose you have like only one server, then what we can do, the rate limiter will be like simple, right? Suppose you have only one server, so you can easily use concept of hash map, right? Basically a storage engine. So you can, so suppose you have a uh, API, which is like, suppose uh, fetch profile, right? Suppose like this, you have a API for something like profile, or suppose login API, right? So what you can do, you can just, let me delete this is a API. So what you can do, you can just put a hash map, and you can say like this uh, and you can put like this login API is like, for, you want to allow your system, like suppose in 1 hour uh, you are allowing a kind of 100 requests, right? 100 login or 1000 login, it's on you. So the simple thing would be, you can put like this login, and in hash map you can put like uh, uh, this kind of last time stamp. So why I'm putting timestamp, I will let you know that as well. So this you can put login and last time in stamp in hash map. And you also maintain a counter, right? Because you need to maintain a counter, so that you can count. Initially that counter will be set to 100, right? So once and it is for 1 hour, right? This count is 100. 1 hour it will be reset. So so basically for 1 hour. So this is how it is, very simple thing. So how it will work is, once your request comes in, and it will be like checking, okay, it's the API is login. So it will check in that map, okay, what last time step. If there will be, for the first time, there will be no in Hasman, there will be uh, no no object in that hash map, right? So it will put that object, and it will put the timestamp as well. But for the second time, once the request comes in, what will happen, since we already have the key login in that map, so what it can do, it can check the last time stamp, and it can do, so it can do like current count. So it will do like this. So we know already per hour you are doing this, right? So what we can do is uh, mm, so you can just simply say current count equal uh, so your now minus last time, current time, you can say current elapsed time. Basically you can call this elapsed uh, elapsed time. So now minus this last time stamp. So it will give you like it will give you the elapsed time in second. So you can convert 11336, right? So basically if it is like uh, so in 1 second, suppose not in you can second, in 1 minute I am going for 1 hour, right? You can, for simplicity, you can take in 1 minute. In moment I will reset the count. So we'll get this one, and what we can do is, so it's a simple logic, right? If you can think about it. So suppose you are getting like suppose uh, the second requesting just in a second, in like 5 seconds. So this the difference will be 5 seconds. So it is kind of less than 1 minute, right? So it's less than 1 minute. So if you do this, so what you can do, the logic would be, you can do simply count uh, plus equal whatever count you have, this elapsed let me pull this so that it will be in one line only. So this elapsed time, right? Elapsed time, whatever it is, into the rate, basically, right? So this is 1 minute, right? So basically it's a 1 minute. So right now we have 5 seconds. So 5 seconds we have into in a second, if you think, it will be like 0 point rate. So if it is the rate, if it will be like less than 1 minute, so it will be, the count will remain the same. If it is crossing this 1 minute, so it will add 100 basically. So in this way you will have the counter will get set and set every time, every in 1 minute. And also for each request you will be reducing the count as well, and you will be setting into this map, basically putting into the map in the on the same key. So this is for login API, and you can do the same for like every other API as well. This all operation right now in memory, but suppose somehow it's for like single server, right? In this, what is the flaw in this design? Suppose it's the server went down, and you, in that time, you don't have anything, and once the server is started, so you don't have this control, right? You don't have this hash map. It will be empty because it was in memory. This is the one flaw. And other flaw would be, suppose you will right now it's a single server, right? Suppose once you scale, you will have multiple servers. So this you need to define in each has map. You define in each server. I mean, this will have in like, this will be the this hash map will be like, they will have their different uh, in that they will have like different hash map and everything. But once the request comes in, so suppose there is once you scale, there will be couple of more server, right? Server 2, then if I can copy paste server 3, with basically it will be on same image will be there, just the replicas of it. So since this, and there will be a of course load balancer will be there, which will route. So I can put load balancer, I can put service mesh as well to route the request. So if I can search something for like load balancer, what kind of image. So okay, let it be. So I think this makes sense. So you'll have load balancer, it will route to different. But once you suppose, once the request go on server, this server, basically server 1. So what will happen? This server only will have your hash map, which will have login key and the last time. This server doesn't know. This server also doesn't know for that request. So once the suppose all this uh, first request 90 first request comes here and second request comes there, goes there, right? So they will maintain, each server will maintain their own hash map, their own like count, right? So this is not, and you will be expecting once you send the 100th request, so you will be expecting at 101 in a within a minute it should throw 429, but it will not, because since it is already, we don't know about this server what count they hold right now, right? We don't know. So that's why in distributed, in distributed kind of system, so you don't know, because each server will have their own hash map. That's why you try to think differently, right? you then you go for, then you will go for like, can we have central kind of system, so that instead of maintaining the counter here, we can maintain somewhere else, and we, each server will get to that particular service or particular database or anything, and they can have from there, and in that term they will have like, each server will have same count, right? And in that way we will have a perfect perfect count controller. So what we can do, for that only purpose we can introduce, uh, so there are two ways to go. Either you can have a service, right? And or service, or you can have the database. You can have database as well to maintain this count. But why in right now in any companies or anywhere we don't use database for rate limiting? The basically the main reason behind it is latency, because you don't want to lose your latency in rate limiting call, because after this you need to do a lot of processing, so we can't afford to lose even some amount of your, some percentage of your latency in that part, right? But in, if you are using database, not, it's not a huge loss, but still it will be slow, because it will, you need to pull this data from the disk and check this, and again you need to also update it for sure. So there will be like couple of network calls will happen, and also it will be slow, because it is getting 7 disk, right? So this is IO call, and for sure disk is bit slow. So rather than using database, what we can do is, you can go for something which is very fast in those terms and have a kind of key value concept, and puts everything in memory. So the best tool out there, or you can say the best service out there is Redis. So Redis is, it it, it, it it is getting used for other purposes as well. It is getting used for DB, it is getting used for queue, messaging queue, and it is also getting used for like this purpose, rate limiting purpose, because it allows you, it has a automatic operation, which we call like INCR, and it has all, it has many things. So I will talk about this as well. So what we can do is, we can uh, put Redis here. So we can do in between Redis. So if I go right, I can type Redis. Probably they will should have Redis. Yeah, they have Redis. Yeah. So you have Redis and you have this. So right now this problem will the get solved. So the algorithm which I here talked about, it is nothing but one of the rate limiting algorithm, which is token bucket token, basically I should call. So this is, I am deleting for a timing. Yeah. So what will happen right now? So this will talk to Redis. So So once you send the request, and it will have the same key value pair, right? And the same thing will happen here as well. It will have key as your uh, key as your partition. Basically, we call as key would be the same which I talked about earlier as well. Login API, and the value should be last times uh, last time stamp. And there will be a also uh, you will put here rate basically, right? Not here, I will talk about it. So this will be the key value here, and same we will do once the request comes in, it will go here and it will check last time stamp, and it will we will do all the calculation which we are doing here, the rate, and if you will have, we will update this last time stamp also. Also there in the same in the Redis we will also store the basically not this, we will store the token as well, token or count, you can say counter. So each request consume one token or one counter. So for initially you can set as per your need, like however you want your system to behave. So you can suppose set 100, and you can put like this rate would be uh, like 1 minute. So every 1 minute it will refill the counter, refill the token or refill the counter, you can say. So right now you are not doing anything, it is happening in Reddit itself. Once you, but you are calling whether like this will yeah, there is two things. This you will store in Redis, this concept, but still uh, your logic would be in your server itself. You should calculate the rate and you should update the token and everything. That is one thing. So right now, at least what we solved is we have a central system, and we are good with our distributed system, right? Either we can have multiple servers because we have a count. So for that API, we are allowing 100 requests per minute. So we solve this using Redis. What was happening before? I'm trying to pull that out, right? So what was happening before? Suppose you don't have Redis, you have everything implemented at server level. So this will also have its own map. It will also have its own map. It will also have its own map. So each can serve up to 100. So what will happen? This will have 100. This will have 100. This will have 100. So in a minute, they can serve 300, which I don't want. My design was I only need to allow 100 requests per minute. Sorry, per minute. So wireless I was not able to control because they will have their own maps. But right now through central service like Redis, we can talk with Redis and we can have only one counter across the servers for that API, right? So this is what Redis does. They what they do once you create this, right? So there is a concept of bucketing. So what Redis will do, Redis will create a bucket, and it will have like this will login kind of. So it will have for login, and you can have for other APIs as well. Like what do you mean by other APIs? So if I copy this, so you can have for like same like profile, something like you can have n number of buckets, right? If you can have. So there would be one question here comes. So suppose since there is a concept of counter, right? Suppose two requests, let's talk about concurrency. So suppose two requests comes in, once they will come to server and they will read, like suppose one request goes to server 1, request goes to server 2, both will, suppose there is a count of, let's talk about, so once the two request comes in, and they each read each read count as 5, because so once they they will serve, right, each, so they will, once they process the request, since I already told you each request will consume one token or one count, so it has to be 3 if you think logically, but since they have read this count or token as 5, they will update this as 4, because it will also update to 4, server 1, it will also update to 4, so it will remain at 4. It should be 3, but it will be 4, because they read at the same time, they updated at the same time, so it will be 4. So this problem is basically called rest condition. So to solve this, we need to have something atomic, so that only one request can go through at a time, and if second can wait for that particular key, right, that particular key for sure. So what we do for this, we have couple of operations. So either there is in Redis there is a concept of compare and set, CAS. This you implement it at server level, compare and set. So what it does, basically what's this purpose of this, so compare and set, what it will do, it will read the counter. So suppose once you call this login API, right, and so this compare and set, it provided by Redis only. What it will do, it's a library of we basically SLF4j in Redis. This is a framework basically. So what it does, it will, once you read the count, they will have version. So suppose C count 5 or token 5 has a version v1. Once you read, you will have version v1. So you will consume one token, you will reduce to 4. Once you go for update, so you will check the version is same or not. So if in that time there is no other server updated the same value for the same key, so it will be remain as v1. But if in a case if someone has updated this, it will become v2, right? So in that case, once you are going for update, so you'll compare whether the version which I have read before updating, is it the same or not. If it is different, it means some other service has already updated, so you will retry. Basically we will again read that counter, the new counter, and again we will do. So this way you are getting saved by this race condition part. But what we are losing here, the time we are losing, because it will keep retrying until some threshold which can be set by you only, but it will take time. There will be a couple of network calls, there will be if it will not go through, it will again retry, and finally whether it will say, yeah, you are allowed to process, you are allowed to go through for this request, or it will send like too many requests, and whatever status post you have set for this. This is what compare and set is all about. And other concept is, we have Redis allows us to use lightweight script, which is, if you compare with, like, as same we have stored procedure, right, in MySQL. We can run that stored procedure in one transaction. In that you will have like atomic nature. In that we can do lots of things. And also, what's the benefit of a stored procedure? This is not about like DB, but since I am trying to correlate, So in stored procedure, what we can do, there will be only one network call, and then that stored procedure will execute by your DB, not by your server, application server. That whole stored procedure will get executed by your database. Same way, Redis also have something called Lua script. It's a lightweight script where you can just mention what you need to do. Like it is atomic, you can control, and it is pretty fast. Since it is low, you don't need to worry about, hey, I am locking this, so whether it will have like issues or latency or not. It won't. Very minimal, but it is damn fast. So what you can do, you can just put a Lua script. In that script, you do all this. But you do all this, like all the logic will be there only. So for rate limiting, since we have just simple logics, you can put in Lua script and you can execute on Redis server itself. So that takes care of your atomic nature. It will take care of your rest condition because it's atomic. So for that key, if another request comes in, it won't allow that. It will say, hey, hold for a certain time, since it's already in use. So that way you can control the rest condition. This is this is this this is what all about rate limiter. So one more thing I wanted to highlight here, since I was talking about distributed rate limiter rate. So in this way you can track off for all those APIs. You can create a bucket and you can put the key value pair as login and this time as temp, right, and the counter, everything, and the rate of it. So this also, this can be this you need to. So what will happen, right, for each API there can be different if you want to kind of have different algorithm, right? For each API you want to have like uh, I want to use for one for this API I want to use token bucket, for the API I want to use sliding window. So sliding window is another algorithm of implementing rate limiting. So what we can do, you can just have config files which you can cache in this Redis. And what it will do, once you go for once your request goes through, it can pull this config file from that Redis, and it will know, right, what for this API, what's the rate limiter algorithm I need to use, or what's the rate for this, like refilling of token, or depending on the algorithm what you're gonna use. That we can have the, you can just cache those files, right, in Redis, or you can also set up some service which can give you that file. So since this is more like very static file, it won't change regularly by regular basis, so uh, you can put that in Redis for sure. So yeah, this is all about rate limiter. Yeah, thank you.